Okay, so in this video, I want to talk about the relationship between algebra and geometry. Because understanding this relationship will allow us to think and reason in higher dimensions. So, to the ancient Greek mathematicians, numbers weren't just symbols that we scribbled down on a page, they were represented as physical entities. For example, the number 3 was represented as a line segment of length 3. And similarly, a number 4 was just a line segment of length 4. And to add two numbers, you would just place one line segment after the other. So 3 plus 4 was just this long line segment of length 7. Now to multiply the numbers 3 and 4 visually, that is to draw out 3 times 4, all we would have to do is repeat 3 4 times. As such, you would have 3, you would repeat it 4 times. And 4. And we would get this rectangular shape with sides 3 and 4. So we can see that multiplication amounted to forming rectangles. And in general, for any two numbers a and b, to multiply these two numbers visually, all you would have to do is form a rectangle with a and b as its sides. So a times b is just a rectangle with sides a and b. Now, what would the expression a times b plus c mean visually? As we've learned, it would mean that we have to form a rectangle of sides a and b plus c. So let's do that. We have one side here that is b plus c and another side here that is a. And this is a times b plus c visually. Now let's do something interesting. From the point where b ends and c begins, let's drop a perpendicular to this point. And now we can observe that the rectangle a times b plus c is divided into two regions, this one and this one. And this region has the value a times b. And this region has the value, this is a times c. So the entire region has the value a times b plus a times c. So for the entire expression a times b plus c, we have discovered a new value, that is ab plus ac. This is called the distributive property of multiplication over addition, and it is the most fundamental rule of mathematics. Now, how can we visualize the expression a plus b whole squared? This is the formula that we are all need to memorize in school. A plus b whole squared is just a plus b times a plus b. Now, this is just two numbers being multiplied by each other. And we've learned that to do that, all we have to do is form a rectangle. So let's do that. We have one side a plus b and another side, let's say, b plus a. We form this beautiful rectangle. You can see it looks very nice. And with the sides a, b, and a, b. Okay. Now what I've done here is that I've dropped two perpendiculars from the points at which a and b meet. So this is the first perpendicular and this is the second perpendicular. And these two perpendiculars have divided our rectangle into 4 regions. And each of these regions has a value which we can figure out. So this first region here has value a times b. So it's just a rectangle with sides AB. The second region here has the value b squared because we have b times b, and that's a square. This region here has the value a times b as it's a rectangle with sides a and b. And this one, although it doesn't look like a square, forgive me for that, has the value a squared. It's a times a. So the entire expression a plus b whole squared has the value a squared plus ab plus ab plus b squared. Let's write that down. A squared plus ab plus ab plus b squared. We can group these two together and get a squared plus 2ab plus b squared. We have discovered another algebraic identity using this beautiful geometry. Now what about a plus b whole cubed? How could we find an expression for this visually? It's possible, but we would have to imagine a cube in three dimensions. And this cube would have many towers and boxes that would merge together to form some kind of expression for this. Now that's quite difficult to do, but it's still possible. Now if we go to a plus b to the fourth power, this is a square in 4 dimensions. Can we even think of visualizing this? It's impossible. But mathematicians don't care. They still want to find a way to think and reason about these higher dimensional creatures. And that's where algebra comes in. Algebra is the realm of symbols. Now, thinking and reasoning about these higher dimensional creatures is actually not very hard in the realm of symbols. Because a plus b whole cubed is just a plus b times a plus b whole squared. And if we tackle this purely algebraically, we have the expression for a plus b whole squared, as we discovered in the previous section. And then we just use the distributive property that we learned in the first half of this video to find the expression for a plus b whole cubed. Similarly, a plus b to the fourth power is just a plus b times a plus b whole cubed. And we have the expression over here for a plus b whole cubed. We can again just write it out in this fashion and get the expression for a plus b to the fourth. Now this is very powerful because geometrically we would have no idea how to visualize this creature. And the same way, we could get to a plus b to the fifth power, we could get to the 11th power, and in fact, we can get to a plus b to the nth power, where n could be any number you want, and our formula would spit out the expression that is required. So we can see that mathematics is the only place that allows us to think and reason in higher dimensions. But the real question is, who cares? I mean, who cares about a plus b whole squared and scaling it to higher dimensions? Now, to answer this question, let's imagine that this diagram for a plus b whole squared is our beautiful friend Lara. Right? Now, we look at Lara and we think, wow, she's beautiful. You know, she has a nice smile and she has nice eyes. And we become curious. We like what Lara is showing us, but we also want to see what Lara is hiding from us. Now, to find out what Lara is hiding from us, we have to go to a higher dimension. So we go to the third dimension and we take another look at Lara. And Lara looks unbelievable in the third dimension. And we want to see more of her. So we go to the fifth dimension and we are completely blown away. Now we are in love with Lara and we want to see everything. We just want to see everything. Now, to see everything we have to go to the nth dimension. It is only in the nth dimension that we will get a full picture of Lara. Now, what do I mean by full picture and everything? Of course, mean Lara's heart and Lara's soul. These are the important things about Lara. And mathematics can help us in revealing these deep truths about Lara and life. Thank you.